101. Now under the pod 101, we will cover what is pod, what is pod deployment. We'll talk about running a multi-container application inside a pod. We'll talk about pod networking, inter-pod and intra-pod networking. We'll also see the life cycle of the pod, and then we'll start with the pod manifest file, where we are going to use an OpenAI plugin to just go ahead and build those pods. So let us get started. Now, pod is a scheduling unit of Kubernetes, just like virtual machine in VMware, container in Docker. In Kubernetes, we call it as pod. So each pod consists of one or more containers. Okay. And in most of the cases, there will be one container, but there is a possibility to run one or more container inside a pod. So the primary advantage of the pod is that we can deploy a multiple dependent container together, because it acts as a wrapper around those containers, and we can manage these containers using a pod. Now, what are Kubernetes pods? In Kubernetes, pod is the smallest and most basic unit of deployment. It represents a single instance of running process within a cluster. The pod encapsulates one or more containers, storage resources, as well as the networking configuration. Now, there are few of very key highlights we need to know about the Kubernetes pods. As we have already learned that we have a pod, which is an atomic unit in Kubernetes, which means that it represents a single deployable entity. It can contain one or more containers that are tightly coupled and share the same resources. And when I say resources, it means that networking, namespace, IPC, we call it as an inter-process communication, and also it includes the storage volume. Now, pods can be created using a command, just like kubectl create command, or it could be through a manifest file, we'll call it in the form of a YAML or JSON file. Now, when we talk about containers within a pod, typically a pod contains a single container, but it can include multiple containers which are co-located and co-managed, which means that these containers share the same context. They allow them to communicate and share the resources effectively. For example, you might have a web application container and a sidecar container that handles the logging and monitoring within the same pod. Now, we already talked about the shared resources, right? The containers within a pod can share the same set of resources, including the same IP address and port space, and they communicate to each other using the local host. This allows the containers within a pod to interact via inter-process communication. Now, you might have a question especially about the lifespan of pods. So pods are designed to be disposable and ephemeral, just like containers, right? Which were ephemeral in nature. So these pods can be created, can be scheduled, can be destroyed dynamically. And Kubernetes manages the life cycle of the pod. So we do have one of the slide where we talks about the life cycle of pod. So what happens if pod fails? So if pod fails to start indefinitely, so we can use kubectl describe command to know what's going wrong. So this is basically for the debugging purpose. So let's move ahead. Now let's spend some time to understand workflow of a pod, how the workflow of creating a pod typically look like. Now on the left hand side, you see that we call it as a pod manifest. A pod is defined using a YAML file or a JSON manifest, which basically describes the desired state. So when we talk about the orchestration, it is all about reaching out to the desired state configuration. And that is where you have a manifest file where you specify or declare those desired state. So the manifest file includes the information like pod name, container specs, we call it as a container specification, networking details, and any other additional configuration that basically goes into the manifest. Now, when you apply the manifest through kubectl apply command, what happens? Basically, it applies the pod manifest and it creates the pod. Now, the first thing which comes into the picture is API server validation. When you run a kubectl apply command, it basically sends the pod manifest to the Kubernetes API server, and this API server does the role of a validation. It validates the manifest syntax as well as it checks for any conflict or any error. The next thing is pod scheduler. Now, once the pod manifest is validated, the Kubernetes scheduler assigns the pod to a suitable worker node. The scheduler takes into the account factor such as resource availability and then node affinity rules and other scheduling constraints. Then the container creation comes into the picture. So assigned worker node receives the pod specification and initiates the creation of container within the pod. So during this phase, we have a container runtime, just like Docker and containerd. It basically pulls the container images specified in the pod and then it starts the container. Next step is the pod status. The pod goes through a different status phases like pending, while it is being scheduled, running when the containers are successfully started, and completed or failed when the pod's primary container finishes execution. And the last stage is monitoring and logging. So Kubernetes provide you with various monitoring and logging mechanism to track the status, the resource uses and events related to the pod. So this is all about the workflow of pod. Now let us understand how these pods are deployed. First, to deploy the pod, we write pod manifest, which consists of container images that we are able to deploy and submit to the API server. And this API server is nowhere but in the master node. After that, API server and a scheduler component in the master node decides and deploys the pod onto appropriate worker node. Now, as you can see, inside each pod, there is one container, which is highlighted in yellow color. So the container is encapsulated inside a pod. As you can see that there are 4 instances of same application running in the worker node, right? Now, this is good, but how about scaling those pods to accommodate the increasing traffic? Now, as the time passes, there might be a chance where there is a more load into the website which these pods are running. So user need to go ahead and scale this. So we need an additional instance of this web application. Now, to share the load, the question is how you scale this application now. If you are thinking of adding a new container in the same pod, the answer is no. We create new pod altogether with the same application instance. And as you can see, now it has deployed 2 new instances here, right? The one, the container and the pod, which you can see in the yellow. Now there could be a scenario where you have 2 containers in the same pod. The helper container gets created with app container and you want helper container to live along with the app container so that they can share the same network space. This looks good, but what if the node resources is getting insufficient? Say you have bunch of containers running inside a pod and pods, the number of pods are growing. And as you can see here, you have 2 pod 1 and pod 2. Okay, so as you can see here, the number of pods increases, right? And if the node is insufficient, the resources in the node is insufficient, like the CPU memory. So what happened that one of the things which you need to do is you need to add the worker node to it, which means that if you have say 3 node master node cluster, and if you are finding that one of the worker node is unable to handle the heavy lifting of these pods, then you don't really run more than 1 containers in a pod. But what we do, we add a new worker node, and after that what will happen that few of these nodes will get shifted to basically your new node, or you add some kind of a replicas to it. Replicas means the copies of those pods, right? So if node resources is getting insufficient, the next step would be you start adding the more nodes. As you add more nodes, there is a high availability, fault tolerance, everything comes into the picture. Kubernetes takes care of that, but we will have a separate session for that. Now, as I said, there are chances that there could be a scenario that you have 2 containers in the same pod, and helper container gets created with an app container, which you can see here in the worker node, and you want this helper container to live along with the app container, but they share the same network namespace. Let's jump into the new topic called as pod networking. Okay, now say you have 2 pods, which is pod 1 and pod 2. Pod 1 has 2 containers and pod 2 has just 1 container. So in pod 1, you can see main controller and supporting controller, and then pod 2, you have a supporting controller, which is basically a container. Now every node inside a Kubernetes cluster has its own IP address, which is called as a node IP address. Okay, so if you talk about the main container and supporting container, basically they have their own IP address. Once we deploy a pod in Kubernetes cluster, it gets its own IP address, and each pod inside a Kubernetes cluster will have a unique IP address that you need to understand. But what distinguishes them? If I have a number of applications running, what distinguishes them? And that's where the ports come into the picture. Now, as they are part of pod 1, it uses pod 1 with your port number. So think of it as like, if my pod 1 is basically has an IP address of 10.0.30.50. If I have any container, then each of these container will be assigned with a different port, and now I can access it through 10.0.30.50 colon 8080 or 3000. Okay, so containers within the same port will share network, same C group and same IPC names. Okay, so this is how the pod networking works. Now the question is, how does this container inside a pod communicate with the external world? Because internally it's okay, you can access through the port, right? But the external world want to access it through some kind of an IP address, right? And that's where your inter-pod communication come into the picture. All pod address are fully routable to the pod network. Okay, so let me show you this. Yeah, so this is the pod network which you see right here. So all pod address are fully routable to the pod network, which means that when you install a pod network plugin such like Flannel or KubeRouter or something like that, each pod gets its own IP address, and every pod can talk to any other pod. Say pod 1 talks to pod 2 through this particular address, so there is no need to mess up with any of the port mapping. So it becomes so simple, right? Now this looks good, but how does this intra-pod communication takes place? Now let's jump into the intra-pod communication. Now intra-pod communication in Kubernetes happens through a loop-back network interface, which is called localhost. Now when multiple containers are running within a pod, so here in a pod 1, you have a main container and you have a supporting container, right? So the thing is, when you have a multiple container which runs inside a pod, they share the same network namespace and communicate with each other using a local host, which you can see right now here. This means that the containers within a pod can use a standard inter-process communication mechanism like TCP, IP, or Unix domain socket to exchange the data. Now there are few ways in which this intra-pod communication can be achieved. Let me see if I have, so I have captured this particular slide. So the first thing is localhost. So containers within the same pod can communicate with each other using a loopback address, right? Which is localhost 127.0.0.1. So they can connect to each other's services or processes using an IP address and port binding defined within the pod. The second way would be IPC. So containers within a pod can use inter-process communication mechanism just like a Unix domain socket or shared memory to exchange the data. Now this is really helpful when containers need to communicate using more efficient and low-level methods than TCP IP. The third option is shared volume. So Kubernetes allows you to mount the shared volume just like Docker into a multiple containers within a pod, and this enables them to read and write data to a common storage location with a data exchange in between these containers. And the last thing which we have is the environmental variables. Definitely environmental variables can be used to pass this information between these containers within a pod. So one container can set an environmental variable and the other container can read and utilize it. So in one of the demo, we are going to see this particular use case. This method is useful when you want to provide a configuration or coordinate the data in between these two pods or the containers within a pod. So it's important to note that while containers within a pod can communicate with each other using localhost, they have their own distinct network namespace. This means that the communication between these containers in a different pod cannot be achieved through localhost, as they have a separate network stacks and IP address. So for inter-pod communication, Kubernetes provides services and networking features like DNS resolution, but intra-pod communication happens only through this particular use case ways. Now I think we covered most of the stuff you can see right now. Let me go back and see if I have missed any of the stuff. So right now, if you see, we discussed about what is pod deployment, multi-container, how to run 2 or more container inside a pod. Then we covered pod networking, inter and intra-pod. Okay, and we also looked at, especially we talked about the life cycle of the pod, and the next step would be looking at how we can really generate those YAML file. So let us go ahead and look at our 5-node cluster and try to get started with the pods manifest file. We are going to look at the demo, especially the pods. We are going to pick up the same to-do list application and try to run it as pod. Now, as I promised that we are going to use an OpenAI to create those YAML files, because there is a lot of noise around generative UI, OpenAI, and so generative AI, and we need to see like how we can use an AI to help us build those YAML files. So if you go to kubelabs.collabnix.com, there is one section which I have added, deploying Kubernetes via AI. All you need to run is, right now I will show you the single node cluster. So you have to run this particular command to install kubectl AI, and then you have to export the OpenAI key, provide your OpenAI key. If you are on the CentOS or in the Play with Kubernetes platform, you have to run this particular command where you duplicate it and then try to put it in the path variable. And then after that, what you need to do is, we already talked about the kube view, which is rightly set up here. So right now you see that these are the pods and services for the kube view. And right now there are, if I refresh it, there are only one namespace. So what we'll do, we'll try to create a new namespace by name ns2 and try to deploy to-do list application pod into it. Okay. Now these are the steps you need to follow in order to run kubectl AI. Okay, and let me jump into the terminal. So if you look at the kubectl AI, right, so we have a kubectl AI, and I'm saying, okay, create a namespace with ns2 and create a pod named to-do list using a Docker image Ajeet Raina /todo. So we are just trying to create a simple to-do list pod. Now, once I do this, it will create a YAML file for me. Now, it is very important to understand each line of this YAML file, and I'm going to go through that. Okay, so this is a manifest file which AI creates. This YAML file includes two Kubernetes resources, which you can see here. As I said, create a namespace ns2. It created an API version v1. The kind is a namespace. Basically, it shows you about, okay, what is the type of, or what is the kind of Kubernetes object, right? So the namespace is the one. So it creates the two Kubernetes resources, namespace and a pod within that namespace. So whatever the pod which gets created is within this namespace, which we specify it here. Okay. Now, if you look at the section, especially the to-do list section, right? So this is what I'm talking about, this particular section. So the metadata section provides the metadata for the pod, including its name and namespace it belongs to. So right now, if you look at this particular pod, the namespace is ns2, which we have created here, and the metadata name is to-do-list. This is the name of the pod. Then we have a spec section. Spec section defines the desired state of the pod. Okay, and again, containers are within pod. That's why you see a separate section called as containers here, but within that specific pod. Under the container section, it lists the containers running within a pod. So there is a container called as to-do list, and it uses the image Ajeet Raina /todo. So within this YAML, what it will do, if I go ahead and apply this, it will first create a new namespace with ns2 and then to-do list pod within that namespace. So let's go ahead and apply it. Now, once you apply this, okay, you use kubectl command, and when I say ns, it lists me that there is a new namespace which gets created. Okay, so ns is the alias for the namespace. It gets created, right? And if I really want to see the name of the pod or the information of the pod, if I say kubectl get PO, it doesn't show me. Do you know what's the reason? The reason is right now we are in a default namespace. That is the reason. Okay, but things are going to change when I specify, okay, I want you to list all the pod under the namespace ns2, and that's where your to-do list appears, your pod appears. So right now it is in a running state. If I really want to see it in a cube view, I can clearly go ahead, refresh the screen, and I can see there is an ns2 which gets created, and you have this particular pod. The phase is running. It has an IP address. It has a pod IP, as you know, like intra and inter-pod communication, right? All of these things. And it says like what is the start time. And within this, you can see here, there is a container by the name to-do list, and it uses the Docker image called as Ajeet Raina /todo. Okay, I can also look at the full object details, what it has. So this is basically, you get all the information about the IP addresses, if there is a volume mount and all of this thing. But as we are running a very simplistic view, that's why you see all in the limited information. So if I say kubectl describe PO and the name of the pod, okay, and don't forget to specify ns2, it will give you all this information that it has been successfully assigned, pulling the images, it pulled the images this. So you see all the logs here. Now this is good. I have been able to run the pod. I can see the pod. It is good. But if I want to access this application, the to-do list application, what shall I do? Usually we go ahead and try to expose the service. But since we are just beginning with pod, we just will do the manual work. And the way how we do it is you basically go ahead and do the port forwarding. So the port forwarding works something like this. You have a kubectl port forward to-do list, and then you specify the port. Now once I do this, let me verify what is the name of the pod here. It is to-do -list. Okay, so what I'm going to do, I'm going to say kubectl port forward, okay, and the name of the pod, which is to-do list, and then port number 3000. So it says the pod's to-do list is not found. So let me recheck it again, what it shows. Okay, it says that it is running, and let me see the port forwarding stuff here, which I ran a few minutes back, and let me see if I will be able to. Okay, so it says kubectl port forward to-do list. Okay, let me see what is the name of the particular pods. To-do -list ns2. Okay, so you remember we are trying to port forward is, but we didn't specify the namespace, and that is the reason why it didn't allow us to do it. So what I'm going to do, I'm going to just pass ns2 ns2, and then when I do this, okay, you cannot place in a plugin ns, hang on, I just have to place n. So -n is a namespace, and we have ns2, and then port forwarding it, and now I should be go to localhost 3000, and my application is up and running. Watch Amazon Prime. I am able to add pick up my kid from training center, right? So these are the things which we can add. So you saw that how we can go ahead and create a simplistic pod. In the next section, we will see how you can run a multiple containers inside a pod.